Hello everyone, my name is Ashley Goodnight and this is my Reading Week 14 video. So as you've probably noticed, there are no EDX video lectures for this week's topics. Instead of basing this presentation on those, in accordance with Dr. Greco's instructions on CampusWire, I based this slideshow off of Chapter 11.11 and Chapter 8 in the textbook. I also used the brief slides from the 2211 Week 14 Notes PDF provided. Anyways, the main topic this week was angular momentum quantization, so let's get to it. This week, we discussed a bit of the history behind atomic structures. We learned about Newton splitting light through a prism in 1670. In 1835, Charles Wheatstone found that metals emitted different colored flames, and in 1854, Alter and Ångström found this color variation in the sparks of gases. The final people discussed were Niels Bohr and his additions to the contributions of Rutherford. While Rutherford's planetary model predicted a continuous spectrum of light from hydrogen, Bohr corrected this by proposing that the translational angular momentum of the electron can be quantized. We use this equation, the absolute value of angular momentum equals n, an integer, times Planck's constant, which equals 1.05 times 10 raised to the power of negative 34 joules seconds. I had learned about Bohr and Rutherford before in my chemistry class, but I had never learned about this specific contribution. Again, in my high school chemistry class, we covered both emission and absorption. The idea of emission is that objects in excited states will emit photons as the atoms drop to lower energy levels. Absorption is the opposite. In absorption, atoms can absorb photons and go from the ground or a lower state in general to an excited state or energy level. Now that I've covered what I previously knew, let's discuss what was difficult and confusing. Unfortunately, the information that falls into the category was just about everything else. Without the EDX videos for understanding, it was hard for me to really know what this week's concepts were. When I looked at the homework questions, I had no clue where to begin. My suggestion for supplemental resources is definitely the textbook. If you don't know already, this course is loosely based on the 4th edition, Volume 1 of Matters and Interactions. In order to answer this week's homework questions, I'll look for guidance there. I am majoring in electrical engineering. All of this discussion about electrons and the structure of atoms directly applies to my major. For example, at Georgia Tech, they allow students to concentrate on specific areas of study, like robotics or bioengineering. None of these fields would exist today without the work of past scientists and researchers. And some of the fields, like electric energy systems, circuit technology, and electronic devices, explore their work more in depth today. Thank you all for listening. Unfortunately, or fortunately, I will not see you all next week. Bye and have a great winter break.